Alright, so the question for this video is solve y as a function of t for the given ODE and find the interval on which it is a unique solution, right? So the first thing we do is we figure out it's not, oh goodness, that's not very good. Y prime plus 2y over t minus 1 equals 1 minus t to the third power, right? So we realize this is not a separable ODE. It is a first order linear ODE. Actually, anyway, we're going to use the method of integrating factors, and we're going to solve this thing, and then we're going to figure out over the interval, or where it's not a unique solution. So the first thing we do is figure out what to use the integrating factor. We need p of t, we need g of t, and we need mu of t, right? Mu of t equals the exponent of the integral of p of t with respect to t. And let's see. And then the general form of y will be 1 over mu of t times the integral of mu of t times g of t dt, right? So, alright, let's get started. So, in this problem, g of t is 1 minus 2 quantity cubed, and then our p of t is 2 over t minus 1. Alright, we just take everything out that's not y, right? So, and what's left is our p of t. Alright, now we move on to calculating mu. So, let's see, mu of t. Mu of t equals t minus 1, the integral e dt, over that, so we can take this 2 out, so we have 2 exponent, actually it goes here, e to the 1 over t minus 1 dt. And this is just that can be solved by u substitution. U equals t minus 1, du equals 1 dt, so we get 1 over u, du equals ln of u, which then equals ln of t minus 1, and then e to the ln of anything just equals whatever's inside, so then in this case it equals u, so this all just kind of goes away, and we're left with t minus 1, right, times 2, actually. Or actually, it's squared, sorry. It's t squared. So we have t on the outside, and when we raise it to the, when we raise this to the, or raise e to the power of this stuff, this actually goes in front here, and then these cancel out, and we're left with u squared, which is this, right? Okay. Now that we've got that, we need to now multiply this, so our mu of t equals that. Now we multiply those together, squared times 1 minus t cubed dt, 1 over t minus 1 squared. And see here, see this looks, this may be a little tricky at first, but really these two things equal each other. If we take out a minus 1 from this guy, pull out a minus 1, and then that switches these two terms, and then they are the exact same thing. So t minus 1 squared times 1 times t minus 1 cubed equals the integral of t minus 1 to the fifth. Okay, and then we just do u substitution again. So we get 1 over 6 times t minus 1. Actually, it's negative 1 over 6 because of this guy. T minus 1 to the 6th power divided by t minus 1 squared, right? So we pull this squared in, or actually we can cancel that out. That subtract 2 from 6, and we get 4. So we get y equals 1/6 t minus 1 quantity to the fourth. And now we figure out over the interval which this thing is actually unique. And since we're not dividing by anything, see, if we were dividing by t minus 1, it would not be unique at 0. Everywhere except for 0, because then 0 on the bottom, you're dividing by 0. That doesn't make any sense. Or, sorry, not 0, but 1. So if we're at 1, it would be 0. It doesn't make any sense. So, but here it appears to be that the interval is all real numbers. So, and that's it. That's how we use integrating factors to solve a differential equation. And this actually was a test question right here that I had on an old test. So, yeah. So this might be something you could expect on a test. Alright, see you in the next video.